A rogue planet called CFBDSIR 2149-0403 drifts alone. No star, no orbit, no sunrise, ever again. It was ejected from its system roughly 50 to 120 million years ago, and has been falling through the dark ever since. But what's even crazier is that scientists estimate there could be more rogue planets in our galaxy than actual stars. No light source, no warmth, just a wanderer moving through absolute cold. A rogue planet forms the same way any planet does, gas and dust collapsing into a solid body. But at some point it gets torn away from its star. Gravitational interactions with other planets, or a close pass by another star system, can fling a world out into open space at thousands of kilometers per hour. Imagine Earth ripped from the sun in an instant. Then imagine that same fate playing out across billions of years, across billions of stars. Astronomers using gravitational microlensing have detected these events by watching background starlight bend and flicker as an invisible mass passes in front of it. And that is where things become strange, because most of these worlds were never seen directly. They were only felt like a shadow crossing a doorway with nothing visible standing in it. Take a planet the size of Jupiter and strip away its star completely, and you get a free-floating giant with nothing to orbit. These Jupiter mass rogues are the easiest to detect because their size bends light more dramatically during microlensing surveys. In 2011, a joint Japan-New Zealand survey called MOA identified a population of these free-floating giants using exactly this method. Some of these worlds may still glow faintly from their own residual heat, a leftover warmth from formation that takes hundreds of millions of years to fade. But the next one on this list is smaller, colder, and far harder to find because it does not have the size to give itself away. Rogue planets closer to Earth's mass are nearly invisible to current instruments. Without the bulk of a gas giant, they barely bend light enough to register during a lensing event. Researchers estimate there could be trillions of Earth-sized rogue worlds scattered across the Milky Way, each one completely dark, completely silent, completely alone. If you stood on the surface of one, there would be no day and no night, only an endless, starless midnight stretching in every direction. The ground beneath your feet might still hold liquid water, kept warm not by sunlight, but by radioactive decay deep in the planet's core. So what happens if a world like this could still support the basic chemistry of life without ever seeing a star at all? That possibility is the terrifying part, because a rogue planet with a thick hydrogen atmosphere could trap internal heat like a blanket. Some models suggest these worlds could maintain liquid oceans beneath a frozen crust for billions of years, entirely independent of any star. No sunrise, no seasons, no sky full of light, just pressure and heat and darkness doing the work a star normally does. This means life, if it exists anywhere else, might not need a sun at all. But if a planet can hide itself from starlight and still sustain warmth in its core, what happens when one of these silent worlds passes closer to home than anyone expects? That brings us to the ones that matter most, the rogue planets close enough to threaten our own solar system. Because these worlds are invisible, without a background star to lens, one could theoretically pass through our system's outer edge and go completely undetected until it was already there. Astronomers rely on precise tracking of comet and asteroid orbits to catch tiny gravitational nudges that would reveal an unseen mass moving nearby. So far, no such intrusion has ever been confirmed, and every model of our solar system's stability accounts for the extremely low odds of it happening within a human lifetime. But the fact that we would only notice through indirect evidence is itself unsettling, a reminder that a wandering world could be closer than any telescope could confirm. If you've made it this far, into the darkest corners of the galaxy, drop a like and subscribe, because the next category of rogue planet is not a planet at all, at least not by the rules we once used to define one. Some rogue worlds are actually former stars that failed. Brown dwarfs sit in the gap between planet and star, massive enough to fuse deuterium briefly, but never massive enough to ignite full hydrogen fusion like our Sun. Some of the coldest known brown dwarfs, like those in the WISE catalog discovered starting in 2011, have surface temperatures cool enough that you could theoretically stand near one without being instantly vaporized. But here is the unsettling part. Some objects blur the line so completely that scientists still argue over whether to call them massive rogue planets or tiny failed stars. And that ambiguity only gets worse the further out you look, into objects that were never meant to exist as planets in the first place. Sub-brown dwarfs form the way stars do from a collapsing cloud of gas, rather than building up from a disk of dust like a normal planet. This means some rogue worlds never had a birth planet stage at all. They were born already free-floating, already alone. Surveys of young star clusters have found several of these objects drifting, with no parent star ever attached to them. Take an object that forms like a star but never grows large enough to earn the name, and you get a world that has been wandering since the moment it existed. But even objects born free-floating are not the strangest thing hiding in the dark between stars. Consider the rogue planets, ejected not by a single star, but by an entire cluster, collapsing or reorganizing early in its history. Young star clusters are chaotic, with hundreds of stars crowded together, gravity pulling and shoving, forming planets in every direction. Simulations suggest the majority of giant planets formed in dense clusters may eventually get flung out entirely, doomed to drift forever once the cluster settles. This means the galaxy's population of rogue worlds is not a rare accident. It is closer to the default outcome for planet formation itself. And if ejection is this common, the next question becomes just how many rogue planets might be hiding within reach of future telescopes. Right now, upcoming instruments like the Nancy Grace Roman Space Telescope are designed specifically to hunt for these free-floating worlds, using wide-field microlensing surveys. Scientists expect Roman to detect potentially thousands of new rogue planets once it becomes fully operational, transforming a population we currently only estimate into one we can actually count. This would answer a question that has lingered for years: whether rogue planets truly outnumber the stars that once hosted them. No telescope has ever mapped this population directly, and until one does, every wandering world beyond our solar system remains a shadow, a flicker, a mass we know only by the light it bends. And somewhere in that darkness, uncounted and unnamed, an entire hidden layer of the galaxy drifts quietly, endlessly, without a single star to call its own. If this pulled you deeper into the strange empty spaces of the galaxy, subscribe and check the playlist, because there are far stranger things still drifting out there, waiting to be explained.